Okay. Hello, hello. Thank you for your patience. Oh, microphone. Hello, hello. Thank you for your patience in navigating those technical difficulties. I'm going to start with a classic demo. I'm going to, does this come out? Yes. Oh, great. Okay, so I'm going to do a little bit of a demo. And this demo is going to be slow because I haven't pre-compiled anything, because I just switched operating systems for the technical stuff. So let's start by using plots. Can we do this? Oh, what's going on here? Okay, whatever, that's fine. So I should just give my talk and then plots will be pre-compiled by the end of it, right? Yeah, okay. So I'm going to get back to this demo later. So benchmarking, oh gosh, what's going on here? Benchmarking has a few different types of use cases. The two primary use cases are interactive benchmarking. So that's like, I've got a piece of code, I'm going to run it, and then I want to make some modifications to the code, see if I can get it to run it faster, or maybe change the inputs, see how different inputs run. And that's like at the REPL usually, and quick iterations, and you want quick, accurate results. And then there's automated benchmarking, and that's for regression tests, like it runs in CI. And those have a different prior distribution for what your expectations of the results are, because if you're doing automated benchmarks, you're probably running a bunch of benchmarks on every commit, and so most of the time they're reporting not much. But that's another primary use case of benchmarking. And Chairmarks is a benchmarking utility that primarily focuses on this interactive use. A lot of the design decisions focus there. And it also supports automated stuff just fine, but when I'm designing it, I'm thinking automated, interactive first and automated second. Let's see if, nope, still pre-compiling. Great. So targeting here, I want to support researchers and developers, and anyone else who wants to know how fast things go. But also, researchers are developers, so we can think about developers as the target users. And what do folks want? Whether they're researchers or developers, folks are going to be looking for accuracy. That's getting the right answer. You want to know how fast something is, you want to know exactly how fast it is. You want to get the correct answer. And this is actually an interesting concept of what is the correct answer. It depends on what the benchmarking model is. So I want a semantic model that's accurate, that can be reproducible. So I give you a number, and then if you run a certain piece of code, it'll run in actually that much time, which is trivial for big benchmarks, but for micro benchmarks, it gets tricky. And also with accuracy, and this is probably the biggest thing, if I say X is faster than Y, then X needs to be faster than Y. And that's a little bit tricky in some architectures and some micro benchmarking cases, but again, for the most part, it's doable. And it should be fast to execute. You want benchmark results, you get those benchmark results fast. And simple UI, concise invocation syntax, just for those rapid iteration. And that matters for those interactive uses. So there's this fast versus accurate thing. The longer you run your benchmarks for, the more accurate the results are. To an extent, that's unavoidable. And to that extent, we want to let the user decide how fast to run the benchmarks. But for the most part, we can do both. So there's some key techniques to look at for getting fast and accurate benchmarks. First of all, save all results. Tuning should be, whenever possible, continue to use those results to create the final summary. Now, that's not always possible. For example, if the number of evaluations in the tuning is different than the final summary, it would just confuse things to lump that in. So we wouldn't return all results, but almost all. And then efficient tuning. Tuning in Chairmarks takes 5% of the benchmarking runtime, pretty much always. And that's a number I picked because 5% slowdown is fine, and it gives good, robust results. And then the overseer, that performance, that's like the big loops over all the benchmarking. So it should be efficient. So almost all of the runtime should be spent running the actual code that's being benchmarked, not running code in Chairmarks. I really want to demo this. Great. OK, so I'm going to start with a little demo of, whoa, look at the time. Isn't that crazy? That's not what time it is at all. So let's see how long it takes to, OK, I'm going to stop talking for a moment to type so I can type with 2 hands. Oh, only 5 minutes left. Wow. Cool. I'm going to skip the demo. And sorry, those technical difficulties really make this talk struggle. So there's no substitute for large sample size. You gotta run your benchmarks for at least a bit of time. Don't need parameter caching because of efficient tuning. So it's just a 5% overhead. How many of you use parameter caching with benchmarks?
I'm sorry, this really is bad. You have a 30-minute talk.
Yes. Oh, great. Great, no worries, no worries. OK, we're going to do a demo. There's actually 25 minutes left, not 5 minutes left. OK, OK. So I'm going to say, see how long it takes to load benchmark tools. OK, 1 second. That's pretty good. And then I'm going to define a function. F of n will benchmark how long it takes to invert an n by n matrix. So start with an open parentheses, like any good function, at benchmark. And from here, let's see, I want to invert a matrix. So I'll write that. And then the setup, have to set up this. So x equals rand. And then have to interpolate these n's. That makes sense because it's evaluating at global scope, so you have to interpolate. Close parentheses dot time. Zoom in a bit. Zoom, zoom, zoom. OK. That seems right. OK, and then x, let's say from 20 to 20. That's my sample size. And now I'm going to see how long it takes to compute all this. And then when I'm done, I'm going to scatter x and y. And this at time block will only measure the first time. It won't measure the plotting time. OK, great. So this is benchmark tools chugging away. Oh, gosh. Ooh, is it seconds? I don't know what that is. Times? Oh, yeah, it's times. So I have to, great. Times, and then I want the minimum, so I'm going to do that. Great. Great. OK, and now let's see. Oh, keyboard shortcuts. Great. Let's do this in Chairmarks. So Julia using plots, and it's going to be already precompiled, right? Great. At time using Chairmarks. Also takes some time to precompile. Oh, it took longer to precompile because of this package weak dependency. So that's a problem. But 2 seconds is acceptable for precompile time. But I'd like it to be better. And now let's define a similar function. But for Chairmarks, the way we do this is I use @b so people using short function names, ew, terrible. Short macro names, ew, terrible. Don't do that. However, here I am doing that. And the reason is because benchmarking is often a write once, read never thing. And that is so rare in code. Like, how often are you writing code that you're never going to read? How often do you type code as if you're never going to read it? I mean, depends on who you are. And so that's my justification for using these short macro names. @be gets you the full benchmark results. @b just gets you the summary, which is minimum. And now we use a pipeline. So think about what we're starting with. We're going to start with n by n matrix. And then what's next? We're going to invert that. Great. And we want the time. That's all. And now let's do the same x, and then the same this thing, and this will take some time. Benchmarking is not instant. It takes some time. There we go. Oh, and look, it's a little bit noisy. I wanted to use Maki, but Maki took much longer than Plas to precompile. So this is not ideal, but we can run it again. We can run it a second time, and again, it'll take some time, and it's still noisy. You know, different noise characteristics on different systems. And I think that there's some, yeah, I don't know. Benchmarking is tricky. And there's all sorts of things to think about. Maybe it's garbage collection. I'm not prepared to fully analyze all the hardware details that lead to different performance characteristics on the fly on this operating system. I was on the other operating system, but now I'm not, because totally different. Anyway, by the end of the talk, hopefully benchmark tools will have the results, and we can compare the accuracy of benchmark tools and Chairmarks. Now, this was not entirely fair, because Chairmarks has a default runtime of 1/10 of a second, and benchmarks has a default runtime of 5 seconds. So that's not apples to oranges. Presumably, benchmarks is going to be a little bit more precise, right? We'll see when the numbers come up, and we won't get a great representative sample because I only have time to do the benchmark tools once. But to get a little bit more fair, apples to apples, we can use benchmark tools and ask benchmark tools to give us a runtime of 0.1 seconds, which is Chairmark's default. And now this is apples to apples, because we're both asking for 1/10 of a second per trial. And the reason I should say, I need to justify why I'm using 1/10 of a second default instead of 5 seconds of default. Like, is that just less accurate? That seems bad. The reason is I want speed first, accuracy second. If you're using an iterative development loop, oh look, it only took 20 seconds. So that's good, right? I should do a little bit of math. Length of x, this is the number of samples we're taking, 25 samples. 1/10 of a second per sample should be 2.5 seconds. If we look at Chairmarks, 2.6 seconds. There's a little bit of overhead. I'll work on that. Actually, I won't. I'm fine with this overhead. Benchmarks, tools, there's a bit more overhead. So that's why, that's the key thing I'm advertising with Chairmarks, is that it gives you the results quickly. And we want fast first, and then, oh, benchmarks finished. It only took a little bit of time, and oh wow. I'm presuming this is the one, right? We can just double check. But this is very good. I think it probably is smoother because it took more samples. And I can run Chairmarks for the same amount of time, and then I'll get back to it at the end of the talk and see if it's the same. But let me just scatter x, y. Yeah, so much smoother. So this is that point. You can't get away from, like, if you want really accurate results, you have to run it for a long time. No way around that. Chairmarks is not a silver bullet. Perfect results, long runtime. Also, this is an N of 1 sample because we don't have time to reproduce this. And let's see. And when I was running this on Linux, it still wasn't always perfect. So it would get this half the time and it'd be a little off half the time. I'm going to run Chairmarks with this same runtime. So I'm going to say seconds is 236.7 seconds per sample. There's 25 samples. And we'll see how that goes. So now I'm going to go back to the talk. No substitute for large sample size. But we do want quick first, and then once you have your hypothesis, you test it and verify it with slow. So slow second. And you can do that by just setting your seconds to be a higher number. Oh, that's not the button I wanted to press. Okay, parameter caching, don't use that. Okay, user interface. This is one departure from benchmarks, the most visible one. One aspect is those function names are different. Another aspect is the return value. I do need to open up a REPL to explain this stuff. So something folks might be familiar with is at B time. Oh gosh, why is this feels bad. There we go. At B time is the like summary version of benchmarks, and it gives you this, but it just prints it. With at B, we've got this result, and then I can say, I can access it. I can say, what's the time, bytes, so on and so forth. So all the results are returned as objects. If you just want to print it, you have to call display. That's the pattern I decided to go with. If you want to show it, you have to call show. If you want to display it, you have to call display. If you want to show it at the REPL, don't do anything because the REPL automatically shows things. Okay, and then the other key characteristic thing that might look interesting is this pipeline syntax. At B, rand 10, sort. So what's going on here is we've got a setup and then a function that's being benchmarked. And this is a pipeline. It's implicit. Each argument is one part of the pipeline. And so this sorting is timed, the randomness, the rand generation is not. And we've got underscore syntax. This is equivalent. So you can give just a function name, and that it assumes it's a function. Or you can give something with an underscore. And if there's an underscore, that would be a parse error. And so instead, I use the macro to parse that as an anonymous function with the underscore as the argument. And with using underscores as anonymous functions, which is a classic tricky thing to get scoping right, here, the scoping is very easy, very straightforward. Like, where does that anonymous function start? The whole block, the whole argument to the macro is a single anonymous function. And so that's where the underscore comes in. That means this is equivalent to this. Those are all the same. And so that lets us do things like sort it in reverse. Oh, it's slower to sort in reverse. That's weird. I should probably get on that. Yeah. And you can have up to 4 things in the pipeline. If you just have one thing in the pipeline, it's the thing you're benchmarking. If you have 2 things in the pipeline, then the first thing is setup, and the next thing is the thing you're benchmarking. If you have 3, the first thing's setup, then benchmarking, then teardown. And if you have 4, then it's a one-time initialization, then setup, benchmark, teardown. But for the most part, you just need 1 or 2. Great. So that's the user interface. That's what you'll interact with on a daily basis. And the performance characteristics here are the same as if you ran the body that you're benchmarking in the context that you ran that benchmark call. And so that means if you just put the benchmark call in a function, everything will be fast. If it's in global scope, you might have access to non-constant globals. So just think that you're writing a function and use those same performance characteristics. And that avoids the at eval. There's no interpolation needed, no eval needed. You can do interpolation, and that just creates an anonymous function. And that's kind of complicated to think of on its own, but if you're very familiar with benchmarks tools semantics, you can use interpolation, and it's pretty similar. And you can just continue using that same muscle memory. So that's the basic user interface. There's a little bit of ecosystem developed around it. I made Chairmarks extras, which is, I get feature requests for Chairmarks, and I'm like, I don't know, this feels dubious, but I guess it's plausible. But I don't actually want to include it in this package, because I like a small, easily maintained package that's got a cohesive, like, only one way to do things. But then people want features, so I put them in Chairmarks extras. So if you want at B time, if you want at B allocated, like benchmark tools, they're in Chairmarks extras. I have philosophical objections to those in some cases and practical objections in some cases, so I didn't put them in Chairmarks, but it's like Chairmarks but more stuff. And then pretty Chairmarks.jl, which Marco Lombardi made, is Chairmarks, but it displays the results in the benchmarks tools output format. I'd like to eventually include histograms in Chairmarks, but I don't yet. And so that's, if you like the benchmark tools display format and you want to use the Chairmarks backend and front end, you can use pretty Chairmarks.jl. That's the gist of it. Let's see if the Chairmarks one finished. It did, right? Yes, okay. And we get, look, they're the same. One of these is benchmark tools, one of these is Chairmarks. I don't know which is which. And they both have this little lump at 170. That's cool. I wonder what that is. Thank you, 10 minutes left. That's probably real, because it's from 2 different REPL sessions, 2 different benchmarking libraries. So like, that's cool. Something to look into. Why is it slow to invert that matrix? Oh, it's probably just above 128 by 128. That's my guess. Anyway, so they're comparable accuracy if they're running for comparable amounts of time. And if you want to run them fast, Chairmarks give you an answer and benchmark tools just doesn't run fast. Yeah, and if you really just want correct answers all the time with high precision, and you don't care about having to wait all the time, benchmark tools is a more robust platform for that. You could also just like hack on a minimum runtime to Chairmarks, but I trust the user to ask for the appropriate amount of runtime. Yeah, so that's the prepared part of the talk. Now I'd love to hear questions. I'm sure I didn't adequately explain everything.
So I assume it also collects the whole statistics, right? It just prints the average, I don't know, minimum, I don't know. But please print a statistic as well, even on a short version. I'm not talking about histograms. Histograms may be difficult, but that's the most common issue. Like you say, oh, it took 43 nanoseconds. Now, please show plus minus and how much. Otherwise, people make wrong assumptions from it.
Yeah, thank you. So use @BE instead of @B, and then you'll get your statistics. I can do @BE 1 plus 1, and we get the statistics. @B just summarizes those into a single number, and the implementation is just summarize @BE. And so @BE is kind of like the baseline, just like @benchmark is the baseline for benchmark tools. I have a few, so first of all, you asked for standard deviation. I have a huge objection to displaying standard deviation because, or I don't know about huge, but I see that misused all the time. You can compute standard deviation of the results. Like I can, what benchmarks tools does, or rolling this back, what Chairmarks and benchmarks tools do is there's a bunch of samples, and each sample has a bunch of evaluations. So let me just pull up a diagram. Where's the diagram? There's the diagram. This is the high-level implementation of, or this is the high-level implementation of what the function looks like. You run the evals and time each sample. So each sample has a bunch of evals and it gets one instrumentation. And for like 1 plus 1, the instrumentation, the actual function is very fast, much faster than the instrumentation. So you have to have more than one eval. When displaying statistics like standard deviation, it's common to just compute the standard deviation of all these results, all these times that were displayed. But that's not the standard deviation of the evals, because there's many evals within one sample. And it's also not the standard deviation of the possible, if you run that benchmark repeatedly. You'll get you could get very consistent results, each displaying a high standard deviation. So that standard deviation is like an easy thing to compute, but it doesn't, if you want to know something, it's probably not what that thing's telling you. And in general, statistics on benchmark results are very, very hard because the whole statistics field is primarily focused on independently and identically distributed variables. There's parts of the field that aren't, but it's just so hard to, all the statistics are much harder if we don't have that. And the complexity of computing benchmark statistics, I think is higher than the complexity of making a whole benchmarking library. And so for that reason, I do not display standard deviation. I do display min, max, mean, and median, yeah. And those, they're also statistically suspicious. Minimum you can trust, maximum you can trust, although it isn't what you're looking for. Mean you can absolutely trust. Median you can kind of trust. Yeah, so they're simple and fairly doable. Yeah, you got me talking about standard deviations. But the answer to your question is at BE.
Thank you.
Any other questions?
So I like Chairmarks a lot. However, it's not integrated into other packages that depend on some of the format that benchmark tools have. For example, PKG benchmark. Are there any plans to try to be more compatible with those other packages?
Yeah, so some of these packages literally require a benchmark tools.benchmark group as their output. Yeah. And I'm like, come on, like make an interface. I don't want to have to depend on benchmark tools to do this. I made a package called Chairmarks for AirspeedVelocity.jl, and that is just a wrapper on Chairmarks that returns benchmark tools.benchmark group results. And that works for airspeed velocity. It might work for this, for PKG benchmarks. I haven't tried it.
Yeah, airspeed velocity has its own words, so.
Yeah. So the answer is somewhat, and if you have a specific request and you're specific and you like want things to operate, especially if you're willing to do some implementation, like I'm absolutely down to support that, but it's not all present.
Okay. Thanks.
About these two questions. I think you made a very good case for benchmarking is very difficult to do right. And on HPC, it's even more contentious. So do you have do you provide hooks, for example, where I could provide a function that takes an input of the sample values, and then I can go and implement whatever, if let's say I'm a benchmarking expert, I know what metrics I want to look at, and so is there a way for me to provide those to Chairmarks?
Yes, absolutely. Hooks are hard. Return values are easy. I return all the data. So at B does not return all data, it summarizes, but at BE, you get all the times, all the data for every sample, and I can show that at BE. Oh gosh, wrong keyboard shortcuts, wrong operating system. So here we go, and I can do x.samples, and those are all the samples. So the first sample was this one, and that had, it took this long, and it allocated twice for a total of 144 bytes. And I could then look at all of those samples individually, do whatever I want, including basic statistics or fancy stuff. Thanks.
All right, I think we're out of time.
Oh, there's more questions. Tragic.